In this video, I'm going to show you how to read a solubility chart. So a solubility chart can sometimes look a little confusing. Here's an example of one right here, but they're very easy to read and to obtain information off of once you understand the way that they are set up. So we recall that solubility refers to the maximum amount of solute that dissolves in a given amount of solvent at a specific temperature and pressure. And we know from our first lesson that there are three different types of solutions. So saturated is when the maximum amount of solute will dissolve in a given amount of solvent. Unsaturated means that there is still more solute that could be dissolved in a given amount of solvent. And supersaturated means that we have had a saturated solution. There has been excess solute sitting in the container, and we heat it in order to dissolve that excess solute and create what is called a supersaturated solution. This is, again, a little bit hard to do. It's very unstable, but it can be done. And this is where we dissolve more solute than would be normal for a given solution. So knowing these three types of solutions will allow us to read a solubility curve, but also determine what kind of solution you have based on the amounts of solutes and solvents. So when we read the curve of a particular solute, okay, and if you look at the curve over here, we notice that there's all kinds of different solutes that are listed there. There's some potassium iodide at the top, some sodium nitrate, potassium nitrate. All the way down at the bottom, we see potassium chlorate, and we see cesium sulfate listed, and everything in between. So it says it is important to trace the solubility of a substance with increasing temperature. So we notice that temperature increases along the x-axis, and we notice that as we move up the y-axis, we are plotting the grams of solute, so the mass of solute per 100 grams of H2O. So recall that the density of water is 1 gram per mil. So what this means is if I have 100 grams of water, that means that I have 100 milliliters of water. Okay, so these charts refer to the mass of solute per 100 mils of water as a solvent. So how do we read this? Well, what we know is that the curved line, okay, so on any of these solute lines, that represents saturation. Okay, so once we are talking about any point on the line, that means that is the maximum amount of solute that will be able to dissolve in 100 mils of water. Anything below the line is unsaturated. So it means that the solute will dissolve, and I could add more until I get to saturation. Anything above the line is considered supersaturated, okay, meaning that there would have been excess solute, we would have heated it up, but it also means that there's maybe solute just sitting undissolved in the bottom of the container. Okay, so again, it could be right here saying it could be any one of these two scenarios if we are above the line. So it could be saturated if there's crystals sitting at the bottom, or maybe there were crystals sitting at the bottom and then we've heated it up and it is now supersaturated. So if we look at sodium nitrate, we're going to take a look at its curve, and we're going to look at 55 degrees C. So we come over here and we find the 55 degrees C line, and we make our way all the way up to where we hit the line. And when we hit the line, we know that the curved line represents saturation. So this means that a saturated solution that contains 120 grams, we just extrapolate that going across, would dissolve in 100 mils of water. Okay, so anything on the line represents saturation. This is the maximum amount of solute that can dissolve. It says if, for example, we mixed in 140 grams of sodium nitrate instead of 120 at 55, so if we just keep on going here, up to 140, which is right here at 55 degrees C. I'm a little bit off of 55, but that's okay. What that's telling me is because I'm above the line, that this is now going to be too much. It's either 20 grams of solute extra that would be sitting at the bottom of the container, Or perhaps we heat that up. It's sitting there, and then we heat it up so that we dissolve that excess solute. Okay, so you can either create a supersaturated solution, or you'll see a saturated solution with excess solute sitting there. Another example says using the same curve is not putting enough solute in. So if we only mix 110 grams of sodium nitrate, so we're going to come down to sodium nitrate here, and 110 grams at 55 degrees C, we can see that we are below the line, below the curved line. And that tells us that it is going to dissolve and that this will be an unsaturated solution. So that is the essence of solubility curves, okay? Knowing that the lines on the curve represent a saturated solution, anything below is unsaturated, and anything above will have excess solute sitting in the container unless you heat it to create a supersaturated solution.